Welcome back for another deep dive. This time we're taking a close look at a paper all about AI that can see and hear and talk back to you all at the same time. It sounds like sci-fi, but it's real. It's called VITA 1.5, towards GPT-4o level real-time vision and speech interaction.
Real time is right. I mean, we see a lot of these models, but very few can handle so much information so quickly.
Yeah, that's true, and we could talk for hours about the implications of that, but what I'm really interested in is the how.
You mean how they actually built and trained this thing?
Exactly. So less about what it can do and more about how it does it. You know what I mean?
Makes sense. It's tempting to get lost in the big picture, but the real magic is often in the details.
Right. So speaking of details, the paper describes VIA 1.5's architecture as a multimodal encoder adapter LLM.
Catchy, right?
Well, I'm not sure I'd call it catchy, but
Okay, maybe not catchy, but it is a pretty concise way to describe what this AI is all about.
okay, so break it down for me. What does that actually mean?
Basically, it means this AI is designed from the ground up to handle different types of information, all at the same time: images, videos, text, audio, you name it, it can probably handle it.
So it's not just tacking on speech recognition to an existing model.
Nope, this is a whole new beast.
Okay, so it's like having separate teams of experts, each specializing in one type of information, and then a central coordinator who brings it all together.
That's a really good analogy. You've got the visual encoder, which in this case is a model called Intern VT300M. That's the one handling images and video.
Intern VT300M.
Got it. Then you've got a completely separate audio encoder. And this one's been trained on a truly massive data set of speech and transcriptions.
How massive are we talking?
Hold on to your hat because we're talking 110,000 hours.
110,000 hours. That's like listening to podcasts nonstop for over 12 years.
Yeah, it's mind-boggling, isn't it? But it's this massive amount of data that allows VITA 1.5 to really understand and respond to spoken language in real time.
Wow. Okay, so let's say I show VITA 1.5 a picture and ask it, what breed is this dog? Walk me through what happens inside the AI.
Okay, so first up, the visual encoder analyzes the image, breaking it down into smaller chunks of information called tokens.
Tokens.
Yeah, think of them like the building blocks of information for the AI. These tokens represent the visual features of the image, like the dog's shape, color, even its breed-specific characteristics.
So it's like translating the image into a language the AI can understand.
Exactly. Then your spoken question, what breed is this dog, gets processed by the audio encoder, which also converts your words into tokens.
So we've got image tokens and speech tokens. What happens next?
Both sets of tokens get fed into the LLM.
The LLM, the large language model, the brain of the operation.
You got it. This is where the magic really happens.
So the LLM takes these visual and audio tokens, analyzes them together, and uses its vast knowledge base to understand the question and the image.
Precisely. It's like putting together a puzzle. The LLM has to figure out how the pieces fit together to make sense of the whole picture.
But it doesn't just spit out a text answer, right? It actually speaks back to me.
You're right, it actually talks to you, which is another whole level of complexity.
So how does it do that?
Well, it's got this special speech output module that's designed to generate spoken language. But what's really clever is how they use a system called a codec to handle the speech itself.
A codec.
Yeah, it's basically a way to efficiently compress speech into tokens and then decompress them back into a smooth, human-like voice.
So no more robotic text-to-speech voices.
Not with VIA 1.5, they've actually got two speech decoders, one non-autoregressive and one autoregressive. And they work together to make the output sound even more natural and fluent.
It's like having a professional voice actor built into the AI. But training a model to be good at so many things has got to be incredibly complex. How did they even approach that?
Well, that's what's so impressive about this research. They developed a three-stage training process that carefully builds up the model's capabilities, starting with vision and language.
3 stages. That sounds intense.
Okay.
Walk me through it. What happens in stage 1?
So in stage 1, they focus on teaching VIA 1.5 to see and understand visual information.
So like showing it a bunch of pictures and saying, this is a dog, this is a cat, this is a house.
Kind of like that, but on a much larger and more complex scale. They use these massive data sets of images with captions and questions, and they train the model to associate words with images, describe scenes, and answer questions about what it sees.
It's like a baby learning to recognize and name objects.
Exactly. But it's not just about object recognition. The model is also learning to understand relationships between objects, reason about spatial information, and even grasp abstract concepts depicted in the images.
That's pretty amazing. Okay, so what about stage 2? Is that when we introduce the AI to voice lessons?
You got it. In stage 2, they introduce audio data and train the audio encoder using those thousands of hours of speech transcription pairs we talked about.
So it's learning to match spoken words with their written counterparts.
Right. But there's another layer of complexity here. How does the AI know when I'm asking a question versus just making a statement?
Hmm. Yeah, that's a good point. How do they teach it the difference?
Well, they got pretty clever with this. They introduce special input tokens that act like labels, telling the AI whether the input is spoken or written.
So imagine these tokens are like little flags that say, hey, this is someone talking, or this is written text.
Exactly. These tokens help VIA 1.5 differentiate between different types of input and respond accordingly.
That's a neat trick. So at this point, the AI can see, understand images and text, and process audio input. What's left for stage 3?
Well, stage 3 is all about refining VIA 1.5's voice. Taking it from just talking to talking well.
So it's like giving the AI a masterclass in public speaking.
Exactly. They train the speech output module using a dataset of text-speech pairs, allowing the codec model to perfect its compression and decompression techniques, and the two speech decoders to fine-tune the output for smoothness and naturalness.
Wow. So by the end of stage 3, VIDA 1.5 can understand images, videos, text, and the audio, plus respond in a human-like voice. That's pretty incredible.
It really is. But a fancy architecture and a clever training process don't mean much if the model doesn't actually work. So how did they evaluate VITA 1.5's performance?
Yeah, did it pass the test?
Well, they put it through a battery of tests, focusing on benchmarks that measure its ability to understand and respond to images, videos, and speech. They really wanted to see how it stacked up against the competition.
Okay, let's hear about those benchmarks. What did they find?
Well, for image understanding, they used a bunch of different benchmarks, like MMBench, MMStar, MMMU, all the hits.
Sounds like alphabet soup to me. What do those actually measure?
Basically, they're designed to see how well a model can understand what's going on in an image. Can it recognize objects? Can it figure out the relationships between them? Can it answer questions about what it sees?
That's like an IQ test, but for AI.
Exactly.
Yeah.
And VITA 1.5 aced it. It did remarkably well, showing that it can not only recognize things, but actually comprehend the whole scene.
That's impressive. What about video understanding? That seems a lot trickier than just looking at still images.
Oh, it definitely is. With video, you've got the added dimension of time. The model needs to understand not just what's in each frame, but how things are changing from one frame to the next.
Right. So what kind of tests did they use for that?
They used benchmarks like Video MME and MVBench. These are specifically designed to see how well a model can understand videos. Can it generate captions? Can it answer questions about what's happening? Can it even track objects as they move around?
And how did VITA 1.5 do on those?
Pretty well overall. It was able to keep up with other leading models on most of the tasks. But there were a few areas where it struggled a bit, particularly when it came to predicting what was going to happen next in a video sequence.
So like if you showed it a video of someone about to throw a ball, it couldn't quite figure out where the ball was going to land.
Yeah, something like that.
Mm.
Which suggests that there's still room for improvement in how it handles that temporal information, the whole time aspect of things.
Makes sense. So we've talked about its ability to see and understand. But what about the whole talking part? How did they evaluate its speech generation capabilities?
Well, that's interesting because they actually approached it a little differently. Instead of directly measuring the quality of the speech output, they focused on how accurately it could understand spoken language.
Oh, so like speech recognition.
Exactly. They wanted to know how well it could convert spoken words into text. They used benchmarks like Eichel 1 for Mandarin and LibreSpeech for English. Those are kind of the gold standard for testing speech recognition systems.
So did VIA 1.5 pass the listening test?
It did, and with flying colors. It achieved significantly lower error rates than some of the best speech models out there, including ones that are specifically designed for speech recognition.
Wow. So it sounds like they really cracked the code on multimodal AI with VIA 1.5.
Yeah.
They've tackled some really tough challenges, but did they mention any areas where they think there's still room for improvement?
They did. They pointed out that we need even bigger and better training data sets that capture a wider range of real-world situations. Because at the end of the day, the more diverse the training data, the better the model will be at handling new and unexpected situations.
That makes sense. It's like if you only ever read books about cats, you'd be pretty lost if you suddenly encountered a dog.
Exactly. They also acknowledged that the benchmarks themselves could be improved. We need better ways to measure how well these multimodal AI systems are really performing, because it's not just about accuracy. It's about understanding nuanced context, all those subtle things that make human communications so complex.
Yeah, I can see how that would be a challenge. But the fact that they've open sourced the code for VITR-1.5 is huge, right?
It's huge. It means that other researchers can now build on their work experiment with new ideas and contribute to the progress of this technology. It really opens up a whole world of possibilities.
So speaking of possibilities,
Mhm.
what do the researchers think is the next step in this line of research? Where do they see this whole field of multimodal AI heading?
Well, they highlighted a couple of really interesting areas. One is improving the model's ability to reason about the future. We talked about how it struggles a bit with predicting what's going to happen next in a video. Well, they want to take that to the next level and enable the model to really understand cause and effect and anticipate future events.
So not just what's happening right now, but what's likely to happen next.
Exactly. And they also talked about expanding the range of modalities that the model can handle. Right now, it's focused on vision, language, and speech. But what if it could also process touch, smell, taste?
Wow. That would be like a whole new level of sensory input for the AI. It would really blur the line between the virtual and the real.
It would, and it would open up so many possibilities for how we interact with AI. Imagine being able to control a robot with your thoughts, or having an AI that can truly understand your emotional state.
Okay, before we get too carried away with those sci-fi scenarios,
Yeah.
let's take a step back and recap what we've learned about VITA 1.5.
Hmm.
What are the key takeaways here?
Okay, so the big picture is that VITA 1.5 represents a major breakthrough in multimodal AI. It's one of the first models that can handle vision, language, and speech all in real time with impressive accuracy and fluency.
And it's not just a theoretical model. The benchmarks show that it's actually performing really well compared to other state-of-the-art systems.
Right, and the fact that it's open source is a game changer. It means that the research community can now build on this work and push the boundaries of what's possible.
So it's a win-win for everyone. The researchers get to share their knowledge, and the rest of us get to benefit from their hard work.
Exactly.
It really feels like we're on the cusp of something big here.
Oh, absolutely. I mean, think about it. For years, AI research has been kind of siloed. You had people working on computer vision over here and people working on natural language processing over there. But now we're seeing these fields converge, and the results are pretty mind-blowing.
Yeah, and it's not just about the technology itself. It's about what this technology enables.
Yeah.
The possibilities are endless.
Right. We could have AI systems that can understand and respond to us in a way that feels truly natural and intuitive. We could have robots that can work alongside humans seamlessly. We could even have AI that can help us to better understand ourselves and the world around us.
It's exciting and a little bit daunting all at the same time, you know?
So you mean it's like we're standing on the edge of a new frontier, and we don't know exactly what we'll find, but that's what makes it so thrilling.
It is. And I think the fact that this research is open source makes it even more exciting
Yeah.
because it means that anyone can contribute to this journey of discovery.
Exactly. It's not just limited to a handful of researchers in a lab. It's a global effort now, and I think that's incredibly powerful.
It is, and who knows, maybe one of our listeners will be inspired to take this research even further and come up with the next big breakthrough in multimodal AI.
Wouldn't that be amazing? That's what I love about this field. There's always something new to discover, always a new challenge to tackle.
Well said. And on that note, I think it's time to wrap up this deep dive. But before we go, I want to thank you for sharing your expertise with us. It's been a fascinating conversation.
The pleasure was all mine.
And to our listeners, thank you for joining us on this exploration of multimodal AI. We hope you found it as mind-expanding as we did. Be sure to check out the show notes for links to the research paper, the demo video, and all the other resources we talked about.
And keep those brains buzzing. The world of AI is constantly evolving, so stay curious, stay engaged, and keep exploring. You never know what you might discover.
That's all for this week's Deep Dive. See you next time.